I'm live, it says. Excellent. Oh, something happened though. Sorry, I'll adjust you in. That was way too severe. I felt it even as I did it. A little bit better. And okay, we'll adjust it as it. Um, as we get into things. Howdy, howdy. We're getting things going. This is the Sunday Chill Stream. I'm Ryan, the calculus tutor, here to answer your math questions. If you have math homework you needed to finish up over the weekend, right now is a great time to do it. It's still early in the day. I'll be here for a couple of hours to answer your questions. You can sit down, bust it out. And then you have the entire rest of your day to work on the rest of your homework that you probably haven't done. Or play some Fortnite or whatever. I don't know. I don't know what you all do. Visual builder. Oh, perfect. Okay, here we go. Overlay. Get rid of the overlay. Video. Get rid of the video. Come over here. There we go. I forgot to update the website. So we're doing that now. Oh, because I didn't navigate back, it looks like y'all have a black screen. Sorry about that. Come on. Come on. There we go. Hi. Go to thecalculustutor.com to submit your math questions. And that's what we'll work on. We're also in between questions, or during the time when there aren't specific questions. I want to talk about factoring polynomials today. That's sort of the topic of the day. Let's go to that. But for right now, I'm getting the website updated. I'm going to go grab my coffee in just a minute. And we'll be back to settle in. I'll give you all some time to submit some questions. We'll go through the how to submit questions for those of you that aren't sure. Go to thecalculustutor.com. I bet you'll be able to sort of figure it out from there. But if you're having trouble, no worries at all. When I get back with my coffee, we'll go over it. Good, that's on the clipboard. Excellent, excellent. Awesome. All right, that's what we like to see there. So that's updated. You all are going to thecalculustutor.com to submit your questions. I will be right back with my coffee, and we'll get going. See you in a minute. Howdy. How's it going? I'm back. I'm back again. Ryan's back. Tell a friend. All right. Let's do this properly for real now, huh? I'm gonna get better at starting streams. I mean, I don't think I'm awful at it, but I would like to have all of this stuff in place before the stream starts. That seems like a responsible thing to do. Hi, my name's Ryan. I'm the calculus tutor. And as old Texas Paul would say, I hope coffee's as good as mine. Hell, I hope it's better. This is a chill Sunday stream. We're going to do some math stuff, but we're not in a hurry about it. I'm going to set up, assuming there's time at the end, I'm going to set up my streams for the rest of the week. And if I don't, honestly, that's fine. I can do it on the Tuesday night stream, honestly. A note, I've stopped streaming on Mondays for now. Those could come back if it seems like it would be worthwhile. But right now, things are slow enough that it doesn't make sense for me to dedicate more of my time to this when it's not actually doing anything right now. But I want to keep doing it. I want the service to stay available, because it will catch, and I'm going to end up with slow times again as sort of after summer and as new, and as students that maybe discovered this, say, in middle school, and so maybe they start using it and they use it pretty regularly for years, but then they graduate, they don't need it anymore. And so I'll always have to find a new batch, but that's tutoring in general. My hope with this channel, what we're doing here, is it's a drop-in place where you can actually drop in anytime, 24/7, to submit a question. I won't be here 24/7. But you can submit a question anytime, and then I will work on it live, but that live answer will still be available to you, even not live. So it doesn't even have to be synchronous, right? I need to make some shorts and stuff, making that clear. Put some work into getting some traction, maybe. But I'm not trying to blow up. I'm trying to get local traction. I'm trying to kind of make this a service. There might be like a tutor setting up shop like at a public library or something, right? After school, but that's not really how people operate anymore. I mean, it still is. I mean, I think the library, our library here in Eugene probably does after school stuff that would attract students that could then maybe pop in for help. But I'm trying it this way because I don't like to leave the house. So what are we doing here? As I said, I'm Ryan. I'm the calculus tutor. And this is free streaming homework help. So how do you get your question answered? Well, you go to thecalculustutor.com. So if you were to do that, this is what you would see sometime. Now this is what you would see. The Calculus Tutor homework help. And there it is. There's the stream. You can watch it right there. Click on through to participate in chat. Submit a question button right there, right? So you can tap submit a question. It'll take you to the streaming page of my website. This is the home page, and I have a little streaming section, but this is the actual streaming page where all the stuff about streaming sort of lives. It'll scroll you down to the submit homework problem section of the site. And there is a homework submission form that you can click. You can also just email your questions directly to me, Ryan@thecalculustutor.com. And that could be a good way to do things. And then you don't have to come back to the website. You just, once you email me, that should be in your address book, and you just email me anytime you want. But you can also use the homework submission form button, and you could bookmark this form. I recommend you do it on your phone, I think. And we'll talk about why in just a second. Click on that homework form button, and it will take you, well, it will take you here. But before you see this, it pops right up on my screen, but that's because I'm signed into my Google account. So it will probably pop up a screen that says you need to sign into your Google account to access this form. That's because you can submit images of your homework, of the problems you're working on. But in order to submit files through a Google form, you have to be signed in with a Google account. All right, so sign in. If you prefer to use your school Google account, try that. It's possible your district might have your Google accounts locked down in such a way that you can't access the form. I apologize for that. If you have a personal Google account that you can use for this, feel free to sign out of your school one and sign in. That's also why I recommend doing it on your phone, is so you can just take pictures with your phone of your work, and it's right up there on your phone to attach to the form. You don't have to do a rigmarole of getting the images from your phone to your computer to submit them on the form. That seems like way too much work. So that said, get signed in with a Google account that can access it. And if you don't have access to a Google account that can access it, like you only have one Google account and it's like your school one and it says it's blocked, again, I apologize. Just email your question to me, ryan@thecalculustutor.com. It was right back on that the Calculus Tutor website, and we'll go back to that in just a moment. So go ahead and listen to this, because this will describe to you what you need to include when you email me. Everything on this form I would like to also have in the email, but an email is just a blank canvas, right? So there's no prompts. So here are the prompts for you. You have to check the box to say, yes, this is my email address. And then tell me who you are. This doesn't have to be your real name or your legal name or your full name. It's just however you'd prefer I refer to you when I'm answering your question. I'll be like, oh, this question was submitted by such and such. All right, such and such, when you're working on this question, tell me what to say instead of such and such. This is also where you can include your pronouns if you care. Otherwise, I'll probably just use they. And that's all that is. Very simple. Where did this question come from? This is also very simple. I'm just thinking the teacher and the class, right? Mr. Matthews geostats, right? Mix Johnson's algebra 1, algebra B, or whatever, right? Whatever your class is. And that's pretty much it. And that's mostly to help organize the questions and the answers I eventually give to them. As I accumulate these, it'll be nice to be able to organize them. If your question isn't from homework or like reviewing for a test or a quiz, like it's not from a class, it's just from your life, I would love for you to, if you're wondering about something and you think, you think math can help you figure out the problem you're trying to deal with, submit that too. And you can just tell me right here. It's from, tell me where in your life you encounter the problem. But again, just a couple of words, it's not meant to be a barrier. It's just meant to help me get a little context and organize stuff. All right. So the thing we actually care about here is, what is your question? The key here is be as specific as possible. So you don't need to retype the entire problem. You don't need to figure out, okay, well, how do I put a greater than or equal sign in and all that sort of stuff? That would be such a pain. You don't need to do that. Instead, whatever the math problem is, if it's on a worksheet or in your textbook or whatever, you can just take a picture of it. So I recommend doing this on your phone, like I said. You just take a picture of that and attach it. And then right here, so if it's a picture of a worksheet, you probably need to tell me specifically which problem. So you can say, number 7 is the one I need help with. That helps direct me. But I need a little bit more from you, ideally. So be as specific as possible. Direct me to the particular problem in the picture you're sending in. But then let me know what about that problem is giving you trouble, if you can sort of articulate that. So you might say something along the lines of, "Ba, ba, ba, I don't, oops, know how to factor in their number in front." I would understand what that means. I mean, if you're reading that now, you're like, I don't know what they're talking about. I would understand what this means. I'm picturing a particular type of problem in my head, but like this sort of thing, or like I don't know how to deal with the fractions in this. I don't know how to do the graphing part. Like I did parts A and B were great. Part C wants me to graph, and I don't know how to do that. That would be great. You just have to direct me to a particular part. That doesn't mean I'm going to ignore all the other parts. It just lets me know where to really focus my advice and things like that. Um, but it's totally okay if like your issue is like um don't is what we're trying to say there. Know where to start. That is actually specific. You're telling me the part you're stuck on is specifically the beginning. Um, and that's a really common place to get stuck, actually. So like that makes sense. And I can focus when I'm going through the problem, I can focus on what are good ways to figure out how to get started. What are good strategies for getting started on both this particular problem, problems like it, and other problems that aren't like it. Um, and then we can go through the problem, but I can know that the thing that was giving you trouble was the getting started part. And now that doesn't mean like if you had known to get started, you would have known what to do in the middle or the end. So I'll go through the whole problem and make sure. And if you're able to tune in to this live, you can pop into chat and ask clarifying questions. If you're not able to pop in live, the VODs will be available on YouTube. And I will also, because through the form, whether you send in your question through the form or email me, I will have your email address. And so I will email you back with a link to the timestamp in the VOD where I answer your question and a link to the notes. And we'll talk about the notes in a minute. Or a link to the spot in the notes where I answer your question. So you don't even have to tune in live. The biggest benefit of tuning in live is that you can ask clarifying questions, but you could always respond to my email with clarifying questions. And I will respond to those clarifying questions on the next stream. Or if it doesn't seem necessarily like stream worthy, it's just like a quick clarification, I'll just respond to your email and say, oh yeah, that 5 is there because I added the 2 and the 3 or whatever. But yeah, so right there, be specific about what in the question is giving you the most trouble, even if that is, I'm not sure what to do. And maybe you just would like to see somebody work through it so you can follow along because you learn really well that way. That's totally fine too. You can just tell me that. You're like, I kind of know how to do these, but like, I'd really just like to see somebody go through it and explain the steps. So yeah, so describe your problem, be specific, but notice even on the examples I put in there, it was one sentence max, right? So 1 or 2 sentences is all you need to put in there. It's not meant to be a barrier. It's just meant as a space for you to help direct me to the way I can be the most helpful to you. And it's okay if you're not certain when you send in the question how I can be most helpful. Be as specific as possible is what I said. And I was intentional about that. All right, we'll skip past this box here, but down here, attach helpful images. This is probably pretty straightforward. Rather than retype the problem, that's a huge pain. Just take a picture of it, or if it's on Canvas or WebWork or MyOpenMath or Fuel or whatever, if it's an online problem, take a screenshot of it and attach that. That's totally fine. If it's in a PDF, so like if you have a PDF packet that you're working through, or a PDF worksheet or whatever that your teacher handed out, you can submit the whole PDF. Just download the PDF from Canvas or wherever, and then you can just add it That it's especially important if you submit a whole PDF that you're in the describe your problem. You tell me not just which problem number, but which page as well, because when teachers put together these PDFs, sometimes they'll take a page from this one or a problem from this one, right? And so you might have a problem number 3 on page 1, but there might be another problem number 3 on page 8, right? So tell me what page and problem, and just really help me figure out what direct me right to where you want me to go. Yeah. The key with the images, the thing to keep in mind is clear and complete. So clear means I can read the text. So if it's something a picture you're taking with your phone of a physical page, just make sure the text is reasonably in focus. It doesn't have to be crisp and perfect. I'll, I can, I can read pretty blurry text, but do your best. Complete is has a few pieces to it, but one of the big things is make sure you get the whole problem. Don't accidentally crop out part of the problem. So double check your picture before you submit it is basically what I'm asking. Double check it to make sure the text is readable and that you didn't accidentally crop out part of it. The other part with complete though is include any diagrams or figures or charts that are part of the problem. So either make sure your picture includes those or take a separate picture of those things and also attach that. You can attach up to 5 files on the form. Uh, the those figures or other things that includes like a blank things that you're supposed to fill out, right? Like a coordinate axis. Even if it's just a blank coordinate axis, include that in your picture or include that with your problem, because I will do the problem on the exact same coordinate axis that you're supposed to do it on, and that will really help you sort of connect my answer to what the teacher's expecting from you, right? um the other thing with complete is make sure you include the instructions. Oftentimes on a worksheet or in a textbook, there will be a block of instructions, like usually in bold or something, for the group of problems, right? These instructions for the next 10 problems, these instructions for the next 12 problems. Um, so make sure your picture either includes the instructions or take a separate picture of the instructions and send that along. Um, and that's just really important because just having the problem itself, I may not know what if it, especially it's like just an equation. I mean, like, what do you? Maybe you're supposed to solve for one of the variables, but like maybe you're supposed to also do something else. Um, so you just include the instructions, and then finally, the other part of complete could be to include an image of any work you've already done on the problem. So maybe you did get partway through and then you either got stuck or you got the wrong answer. So you got all the way through the problem and then checked your answer and it wasn't the one you were supposed to get. Um, Send a picture of that. My promise to you is if you send me a picture of your work or your notes, just send me, it doesn't have to be multiple things, right? Send me one picture of your work that's relevant to that. So if you haven't done any work on that problem, send me a picture of work you did on similar problems, either in that homework or in class while you were taking notes or whatever, or just the notes you did take in class about that type of problem. You don't have to include that, but it is very, very helpful to me. But my promise to you is if you send me a picture of any work you've done, that won't show up on stream. That's just for me to help give me context and help me understand what you understand, and see if maybe there's some misunderstandings or some gaps that I could fill in that would actually answer the root of your question, right? Um, so there's that. You will notice there is a button you can tap to say yes, you may share the images I submit. That's mostly there because as you get for students like calculus, maybe pre-calc, but like calculus students that are using this service or college or university students, the problems they're working on can get complicated and sophisticated enough that for them, the thing that could be really useful for them is to send in a problem that they've gone through and have me go through their work. Um, so I wanted to make a way for a person to say, I appreciate you not sharing my work, but what I actually need you to do is go through my work. So that's there for them. If that's what you need, if you're submitting a question via email, and that's what you're wanting is for me to check your work for correctness, um, I'm happy to do that. But make sure you include in the email uh, I would like you to check this for correctness, and so it's totally okay if you show this on stream. Um, it'd be a lot harder for me to do that sort of work, checking for correctness, um, on stream without showing your work though, because that's going to be a lot of me doing stuff that other people can't see and that doesn't benefit them, right? Whereas if I can go through your work and actually show it on stream, if that's what you're requesting, that's going to benefit the other people. I can use that as I can instruct as I'm doing that, right? Um, so yeah, but otherwise, if that's not what you're wanting, you're just wanting me to go through a problem and explain things. I will not show your work on stream. Please send something relevant to the problem that you've already done because that helps me help you. But that's just for me. It won't show up on stream. All right, that is our process here. Um, back on the website, you can see, um, like I said, you can email your questions to me, ryan@thecalculustutor.com. Here are the guidelines, which are just the same things as the form asked for, but spelled out right here. Because the idea with emailing me is people emailing me probably can't access the form. But if you find emailing me just an easier way to submit questions, that's great. That's fine with me. But an email is just a blank canvas, and so this is so you can go, okay, do I have everything I need? Again, it's just your name, and that's just a preferred name. It doesn't have to be your real name, anything like that. So your name, your pronouns if you care, where the problem came from, teacher and class is mostly what I'm looking for there. Your specific question, right? Direct me to the question you want me to focus on, but also tell me what about that question is giving you trouble, to the best you can. And then clear and complete images, like we discussed earlier. Nice thing about email is you can include more than 5 images. But I I could choose like 1, 5, 10, or 15, I think, and I chose 5 because that seemed like a good number. If you need to submit more than 5, go ahead and email me. So yeah, so that's our process there. We'll do that. We will go back to the note. Oh, actually, hold on. Let me show you. So the notes you will see in a minute soon, and that you saw at the beginning, um, accessible. The current notes that I'm currently working on are always accessible. Oh, screen's black. Hold on. Let me interact with it here. There we go. Okay. The current note file that I'm working on. So if you're watching me live, is always available here. This one will also usually include at least the current week and right now many weeks back. I will have an archive system set up as it becomes useful and necessary. So for right now, if you're looking at a problem I've worked on in the past, or very recently, you can click this, go to notes, or this is on the home page. There's also a button in that same spot, right? Go to notes. So yeah, so that's how you get to the notes. So you can follow along, or if you're not, so you can, yeah, so you don't have to like pause the stream or like scrub backwards through the stream to see what I did and stuff like that. You can just look at it when you want, as you want, and that seems necessary and useful to me. So these are those notes. There we go. Oops. We are in fact back, so we can get rid of that. So with that in mind, let me check for question submissions. No, stop. Okay. Okay, I don't see any question submissions. So, what I want to talk about today, yeah, okay, it's okay. Ooh, oh, Miro added a new tool. The what are they calling it? The precision eraser. Check this out, y'all. Um, this is gonna be so dumb. You don't care. Okay, so normally, all right. So each of those, this is one single continuous stroke, and this is one single continuous stroke. Right? There's single line. I can click on it. I can just tap on it and move it around. Right? I can tap on this one. I can make it bigger, smaller. Right? Let's make it a little bigger. Right? It's just one thing because I made it with one stroke of my stylus. Um, so before and still available in Miro as an eraser was the current what they're calling the line eraser now. You erase and it just erases the whole thing. Sure, it erases each individual stroke. Um, and that was fine, but it did create some issues. It just meant if you're doing stuff that you know you're gonna probably want to erase to like sort of like you're overdoing it that you want to erase back, you have to do that in a bunch of separate strokes. Which for some people might not be natural or whatever. Anyway, they now have this precision eraser, which can I oh, you can change the size of it. Nice. I'll make it a little bit big. And now with that, see that? I can come through the middle. I can erase just this section right here instead of the whole stroke. Now I'm so curious. What did that do? Did that break? This is all still one item. I think that's how I would want that to work. I was thinking it was going to break it now into several different pieces because the strokes are no longer continuous, but it doesn't care. It's just erasing the pixels, or rather, it's probably just making those particular pixels transparent, right? Okay, yeah. So I do that. Now, if I change the color to say pink, they still say erased. And I don't know what it's doing. It's like actually erasing them. And is this just like a duplicate? It's not treating this like it's a bunch of separate items joined together. It is just I can't. Can I? Fascinating. Okay, wait. What if I? Okay, now I do that. Huh. Okay, so the eraser on my stylus is still well. Yeah, the eraser on my stylus is the line eraser. Hold on a sec. Okay, there's that. We have a lasso tool here. Okay, I was wondering, can I separate these two things? I can't, but here's what I could do, right? I could duplicate it. Hmm, that's weird. It doesn't like it's sort of glitching. Oh, there we go. Yeah, that was weird. I could duplicate it. And now on this one over here, if I erase all of this, does it make the selection box smaller? And does it reduce it down to just that? Now if I tap that, I tap that. It does make the selection box smaller. Now it is just that piece. Huh. All right, fascinating, y'all. This is. I like Miro. I do like Miro. It's. I wish it was an open source tool. I wish there was a way that I could be sure I could continue to access this version of Miro in case the company, in case another company buys Miro, in case leadership at Miro changes or they decide to pivot and like super and shitify it. There is some AI stuff in here, like they have AI stuff, but like look at this interface. I don't see an AI button. I think if I like do like a text box, yeah, there is an AI button right here as a tool, but it's like it's all the way over here, and it's like oh, it's grayed out right now. It's not given any priority, um, which feels a little. Um, oh wait, there is an AI button. I've gotten so used to ignoring it. Okay, create with AI, and it's separate, and it's okay. Never mind. This is exactly the thing I was talking about, but obviously it's subtle. Um, So, and I do get pop-ups occasionally when I log in. It's like this new AI thing, this new like generative AI thing. I'm like, I don't care. Um, all right. Sorry, that was a tangent and a distraction. We'll take the little disruption in process here to check for new questions. Okay. So today, what I would like to talk about is factoring. Um, Polynomials is where we're going to start, but it actually doesn't have to just be polynomials. The ideas, we will talk about processes for polynomials, but some of the ideas here are more universal than that. So let's call it factoring polynomials because that's where we're going to focus. But I do want to point out that a lot of this, besides the things that refer specifically to like if you have a polynomial, do this. But the idea, the reasons we factor or would want to factor all of the sorts, that's more universal than just polynomials. Polynomials are just the ones we're going to focus our techniques on. Okay, so factoring polynomials. Here's the, so sort of, I think a question we need to answer first is what is factoring? And then we'll answer the question, what is a polynomial? Actually, let's just write out some questions. What is a polynomial? I think there's a sub question under what is factoring. Actually, I want to do it as its own separate question. Why factor expressions? So this expression is just more generally than polynomials, right? Polynomials are a very specific type of expression. I'm just talking. So this is sort of the general thing. I think these are our big questions. What is factoring? What is a polynomial? Why factor expressions? And then finally, what we will get to is how, or let's do we'll call it We'll call it techniques. For factoring. All right, and then we'll do techniques for factoring. So that's not really a question, but that's where where we will sort of end up. Okay. So factoring is breaking a value down into multiplicative pieces or component values. Multiplicative into factoring is breaking a value down into a product of other values, usually simpler values. Usually, not always. But the goal of factoring is usually to take a kind of complicated thing, so like a big number, right? In terms of numbers, especially if you're talking whole numbers, the only way to make a number more complicated really is just to make it bigger. Um, and yeah, so we could regard bigger numbers as more complicated and smaller numbers as simpler numbers. And that's what I want to look at. I want to look at an example. Let's look at let's look at 60. 60 equals 30 times 2. So 30 and 2 are factors of 60. We can keep breaking down the factors. 60 equals 6 times 5 times 2. So 6 and 5 are also factors of 60. Let me just keep moving this down. All right, so factoring is breaking a value down into a product of other, usually simpler values. In this case, if we're talking whole number, so notice I'm using the word value here instead of just the word number, right? Because equations are values. They are a representation of value, and we'll get to that. But for right now, I'm focusing on whole numbers. That's a great place to start when you're talking about factoring because I think we can understand it pretty intuitively. Okay, so here's our example. A thing to keep in mind is all whole numbers. Actually, I'm going to say this. All values are either the product of two or more simpler values or are either the product of two or more simple values or are prime. Oops, let's write that. Kind of nice. And this is what a prime number is. A prime number is just a number that is not the product of two or more simpler values. In our case of whole numbers, simpler means smaller. So a number like 13. So let me keep moving these down. Keep giving myself space. Okay. Example. 13 is only the product of 1 and 13, no other whole numbers. Since 13 is not simpler than 13, 13 is prime. This is one way to think of it. We also talk about it, its only divisors being 1 and itself, right? But the reason that itself is important there, because every number is divisible by 1, so it does have one factor that's simpler. To not be prime, it needs to have 2. At least it needs to have at least 2 factors, which means really kind of has to have at least 3 because it will always have 1. This is also tied up. This also gets into why 1 itself is not considered is not just not considered. It is definitionally not a prime number. 1 is only divisible by. It only has one proper divisor. Uh, prime numbers have to have a pair of proper divisors. At least one pair. Or at least a pair, right? Like it could be 3 things you multiply all together. But if you have 3 things, you have 2 because you can always multiply 2 of those together, and then boom, now you have the smaller one and the other 2 that were multiplied or whatever. So, okay. This is factoring. It's the idea of taking a value and breaking it down multiplicatively, right? So like 10, we could break down into 2 times 5. Oh, let me define that. 15 is the product of 3 and 5. So 15 is composite, which is not prime. Boom. It's composite. Composite just means that you have this property of being able to be broken down into 2, at least a pair of smaller values. Oh my gosh, if I could be satisfied with my writing. examples. 13, 15. All right, so yeah, whole numbers at least are either composite or prime. Um, okay. Sorry. I was trying to think if there's anything else I wanted to say about that. Uh, the biggest thing. So I want to talk about prime and composite because they come up and they're like a direct consequence of this factoring. Um, but the factoring is just taking a value, and so right now what we're focused on in terms of value is whole numbers, right? But there's other types of values. Obviously, there's fractions and decimals and negative numbers, things like that. Those are all values, but also variables are values. X, Y, A, C. If if you're using them as a variable, as a placeholder for a value, then they are representative of a value, and therefore they are a value, right? But here's the other thing: expressions and equations and things like that, and functions, and those are also representations of value. So let's move on to what is a polynomial. Okay, so a polynomial is an expression which is a value using variables, numbers, and operations. Okay, so an expression is just anything that uses variables and numbers and the various operations that we know, right? Uh, uh, in the form, oops, ax to the n plus bx to the n minus 1 plus dot dot dot. Oh, actually, you know what we usually do? We usually call this an, and we call this an minus 1. All the way down to a2x squared plus oops, that's supposed to be an a1x to the first. This is supposed to be a 2. I think I want to define this differently. This is a fine definition, and it's true, but I think I want to, especially to focus on this idea of value, I want to first define let's define a monomial. It is an expression of the form ax to the n. Actually, here, we're going to write it like this. We'll say a times x to the n. So, I think a has to be a whole number. Hold on, let's double check this. Okay. Yeah. Okay. So where a is a real number. So a can be basically anything. And n is a whole number, which also means greater than or equal to 0. So a whole number by definition is the number 0, 1, 2, 3, 4, 5, 6, the counting numbers. So negatives just aren't a part of this category of whole numbers. So this is a little redundant, but I just wanted to specify. So what does this mean? It is a number. So this is, so a value, a monomial is a value represented by a number times a variable to a whole number exponent. Monomial is a value. An expression, it's an expression and it's a value. An expression, numbers, if I write just the number 5 on a piece of paper, that would be an expression. Expression is a broad category. There are more specific types of expressions like, well, I guess actually an equation is technically a different thing that uses expressions as part of it. So regardless, you can have very simple expressions, you can have very complex expressions. But they're all just a representation of value, right? 5 is a concrete value, right? We know 5 is this many every time. X is not a concrete value, and depending on the context, we can put some what am I trying to say? Restrictions on what X could possibly be, or if it's in an equation, you know, maybe X does truly only have one value. It's just not being stated explicitly. Maybe we have to solve to figure it out. Maybe we don't currently know what it is, but there's only one value that can make it true. But in some equations, there's multiple values that can make the X value true. And in some equations, there's an infinite number. And in some equations, X could be literally any number because it's a placeholder. So, but it's still a representation of more abstract value. So if you take 5, a known value, and you multiply it against X, an abstract value, well, 5, there's still a value, and X still represents any number that you could conceive of on a number line. So it's a known value times a known number times another number that we could potentially know, or that represents. So a number times a number, that's just another number. But if we don't currently know what it is, it's a lot like x in that it's unknown and abstract. So x and 5x just represent two different numbers, right? Obviously, they're related to each other because they both have an x in them. So if x is 3, then 5x is 15. But if x is 4, then 5x is 20. So we can predict how the 5x value will change based on how x changes. Like, right? So it can be predictable. And that's kind of the idea here. As you're moving forward, that's a big idea in algebra that I don't think we emphasize fully. I think we get too caught up in the techniques early on. And it's an abstract idea that I think we need to keep revisiting. Is the problem is we don't really know when the right time to introduce the idea is, and then we get too caught up in the processes of algebra, and so we never revisit it. Because we never introduce it to begin with, we never revisit it, and it should be a thing we revisit over and over and over again. And that thing is, everything is just a representation of value. The fundamental building block of mathematics is the representation of value, whether that's a concrete value in a number, in a numeral, or a combination of numerals, or it's an abstract value in a variable, or it's a formula for finding particular values in an equation or a function, right? These are all just different ways to write and work with and organize value. Mathematics is just the working of value and the understanding of value. All right. So a monomial is this little representation of value. Instead of being just a concrete number or just a variable or just a concrete number times a variable, we get a little extra, we get a little extra feature. We get the feature of the exponent, right? So 5x squared, or 5x cubed. So you can do a lot of stuff with it, right? And in fact, this isn't even a good time to bring this up. Polynomials are a direct representation of value in a number-based system. That may not make a ton of sense right now. I want to go into this, but I don't think right now is the time, because it's sort of a big idea. But essentially, you can represent the entire base 10 system, or binary, which is base 2, or hexadecimal, which is base 16. You can represent all those base systems as polynomials. And in fact, yeah, a polynomial ultimately is just the most abstract representation of a number in a given base system. You don't have to worry about that, though. Like I said, that gets to a lot of other stuff. And so we won't focus on that right now. Instead, what we'll focus on is this idea of a monomial, this little unit of value that is complicated enough that we can use it for a lot of stuff, right? It has both a right here. This is called the coefficient. Oops. Right? So it's a concrete value, a coefficient, times some number, times an unknown value some number of times, right? That's what the exponent here tells us. Is it's not just 5 times x, whatever x is. Maybe it's 5 times x times x times x, right? Like 7 times or something, right? Or just 2 times, 5 times x, 5x squared. We often refer to this as the degree of the polynomial, or the power. So that is a monomial. meal, right? It's just this nice little nugget of value that has sort of all the things you kind of might need. Has a concrete value. It has a spot for an unknown value, but a way to then take that single unknown value, but make it maybe bigger, right? Instead of just if your unknown value is 7, sure that's just 7, but if you square it now, it's also 49. If you do it again, it's 353 or something like that. I forget exactly what. Now I want to know. I should have my calculator open anyway. $343. Oh, I was so close. Okay. So that is a monomial. A polynomial is 2 or more monomials. Oh, actually, no, I didn't like it. Is the sum of 2 or more monomials. 2 or more. There we go. 2 or more monomials. So mono 1, poly many. MIAL. I honestly don't know what that means. Let's see if we can meal etymology. Animal. Huh. I'm not seeing what meal actually translates to. But I don't super care either. Anyway, yeah, a monomial is just one of these little units. A polynomial. Oh, maybe it's nomial is what I should look up. Nomial etymology. Nominal. No, I didn't mean nominal. Yeah, I'm not getting good results on that. Which is fine. That's a distraction. Okay. So a monomial is just one of these little units. A polynomial is multiples of them being added or subtracted, not multiplied anymore, or not multiplied like in here, right? So a binomial could be like 3x plus 5 or 7x cubed plus or minus 9x. Boom. A trinomial. So binomial has 2. A trinomial could be negative x squared plus 15x minus 6. Or we could have like 5x to the 10th minus 18x to the 7th plus 1 plus 1, something like that, right? 3 pieces, 3 monomials add together. So look, plus 5. 5 by itself is a monomial. It doesn't have an x, but remember, n can be a whole number, greater than or equal to 0. Anything to the 0 is just 1. So 5 is actually 5x to the 0. And actually, I was using x's for all of these. Let's look, this could be a t. These could be y's. You can even mix variables. This could be a y. This could be a z. Right? And then anything more than that we call a polynomial. Right? You could have 6 m to the third plus 10 x to the 2 minus 15, and you could have a fraction here, minus 7/8 y, just y. And then minus pi. Maybe now we just have an x plus 1.27. Boom, right? So you can have fractions in there. You can have fractions up here too, right? Like this could be, this could be 9/5. This could be 1.8. So yeah, monomial is 1, binomial is 2, trinomial is 3 of those little units that are a number, a coefficient, times a variable raised to a whole number exponent. Whole number means 0, 1, 2, 3, 4, 5. So 0 is considered a whole number. There's also another class of numbers called natural numbers that all it does is exclude 0. It's all of those same 1, 2, 3, 4, but instead of including 0, it doesn't include 0, and the set starts with 1 instead. That's necessary. That's necessary and useful. All right. So that's what a polynomial is. A polynomial is the sum. Let's move this over and insert our verb here. Is the sum of 2 or more monomials. The key here is a polynomial is a representation of value like all expressions. Okay, so there's that. So why factor expressions? So we can, just like we can factor known concrete values like 15 can factor into 3 and 5, we can also factor these more abstract, like unknown values, because they still follow patterns. And multiplication still works the same, or an addition still works the same, no matter what kind of value it is, right? Multiplication isn't true for just whole numbers or specific types of numbers. It's true for all numbers. It is defined the same way. So what we will say is, just like a concrete value can be factored, 15 equals 3 times 5, an expression value can also be factored. I should turn this all together so I just grab it. Okay. Expression value can be factored. Example. 2x minus 5 times 3x plus 8 equals 6x squared 16 minus 15 plus x minus 40. So the quadratic trinomial trinomial, there we go. So the quadratic trinomial factors into the product of two binomials. Generally, we only consider a polynomial factorable if the coefficients in the factors are integers. Integers. So if the whole numbers are 0, 1, 2, 3, 4, so just all the counting numbers and 0 that are positive, the integers are just the mirror image of that. 0 still includes 0, but then -1, -2, -3, those sort of things. Okay. Okay, so there's that. This is useful in two main situations. Simplifying rational expressions. So we could go, so if we had that same polynomial, so if we had 6x squared plus x minus 40 over 3x plus 8, like that. Well, we know this is actually equal to 2x minus 5 times 3x plus 8. And we can see both the numerator and denominator have the same 3x plus 8 value that cancels out. And so this complicated expression that's written as a fraction can actually just be written as this. We can realize it's actually equivalent to this expression. Of course, we have to make the note that x cannot equal -8/3. If you're not sure why that is, don't worry about it terribly right now. It is true. It just has to do with the fact that if x was -8/3, this bottom would be equal to 0. Even though it cancels out, because this would be 0 and this is 0, you'd get 0 divided by 0, and that's actually that's not a numerical value. That's what we call an indeterminate form. So 0 divided by 0 doesn't equal anything, just like anything divided by 0 is undefined. And so because this is the expression we started out with, it's not perfectly equivalent to this, because in this expression, 2x minus 5, you could totally plug in -8/3, and you would get a fraction, certainly, but it's still a valid number. It's still a number that exists on the number line. But that's not true for the original expression. If you plug in -8/3, you get the 0 over 0 undefined value. And so we have to take a note of that this is in fact equal to this, so long as we take into consideration that. Because for that one value, this isn't equal to this, because this would be defined and this would be undefined. Does that make sense? So don't worry about that terribly. I'm just putting it there for accuracy and completeness for the most part. So there's one example to simplify rational expressions. You factor the top to look at the multiplicative pieces, just like you would simplify any regular fraction, right? Like 15 over 5. We know 15 over 5 simplifies because 15 is 3 times 5. 3 times 5 over 5. The 5's cancel, and you're just left with 3. You don't have to do anything special like can't equal, because those are concrete values, and you'll never 5 over 5 will never equal 0 over 0. 5 over 5 will only ever equal 1. So simplifying rational expressions. That is one major place. The other major place is solving equations. Get rid of that. Boom, boom, boom. Okay. So we could have, what do we have? We have, what was the 6x squared plus x minus 40. Oh, I can use my other computer to scroll around so I don't have to keep bouncing back and forth in front of you all. Okay, so what if we have something like 4x squared equals, or actually let's do plus 10 is equal to 10. There we go. 4x squared plus 10 is equal to 50 minus 2x squared. No. 50 minus x minus 2x squared, I think, is what I need to do there. Minus x minus 2x squared. Yeah. Okay. So we have this equation, and we want to, so solving the equation means we want to know what value of x makes this equation true. And there's, several ways we could do this that you learn at different times as you're going through math. One thing though, so this is a polynomial, right? Um, these are polynomials. This is a polynomial. We have this binomial is equal to this trinomial. They're both quadratic because the largest exponent is a 2. Um, and because we have x's with different exponents in them being added or subtracted, we'll never be able to combine those together. So when you have when you have a polynomial with more than one instance of your variable with different exponents, you're never going to be able to do a direct algebraic solving. You're never going to be able to just like move stuff away from the x and get the x all by itself. Factoring could be an option. There are other techniques, but factoring is a go-to option often. And so what do we mean by that? So here's what we're going to do. Okay. So we're going to get everything on one side so that the whole thing is equal to 0. And even though it might seem counterintuitive, I'm going to move the side. Oops, that's supposed to be it. I'm going to move the side that has more stuff. So I'm going to subtract 50. Subtract 50. So that'll cancel out. I'm going to add x. So that'll cancel out. So we'll come over and we'll add x. And I'm also going to add 2x squared. So I'll add 2x squared to this side as well. So what we end up with is we end up with 2x squared plus 4x squared. So we end up with 6x squared plus x. I'll just say plus x. Plus 10 minus 50 is minus 40. And oh, would you look at that? It's the same quadratic we've been working with. I just wanted to be consistent. We're going to talk about, I know I'm not giving many examples of how to factor these. That's because we're not there yet. I want to use the same one so that we don't have to keep getting distracted by the process just for now. Okay, and then we know that this factors into 2x minus 5 times 3x plus 8. So yeah, and we didn't even talk about how we factored this. I started with these factors and multiplied them together to obtain this other thing, right? But that's how you can obtain, if you know you want your factors to be 10 and 7, well, then you want a number like 70, right? That would be the first number you could use. But you could also, do 10 and 7 and then put a 2 in there. 10 times 7 times 2 is 140. 140 also has 10 and 70 as factors, or 10 and 7 rather, as factors. So we know this right here and this right here are equivalent to each other. So we know we can just replace this with this and it's still equal to 0. Here's why this is valuable. If A times B equals 0, then either A equals 0 or B equals 0. That has to be true. This is called the actually, let me write this a different way. Why am I doing it that way? Let's do either A equals 0 or B equals 0. And this is called, I'm going to lower this down so I can give this a name. This is called the zero product property. It just has a name. It's the idea that the only way to multiply and get 0 is if one of those numbers is 0, right? There's no two numbers you can multiply that would ever give you a result of 0 if one of those numbers isn't 0. But if one of the numbers is 0, you'll always get 0, right? So 0 has this really useful property mathematically that we can use in situations like this. I'm going to actually make this blue and put a little note box around it. This is going to be a useful thing that you're going to want to be aware of. Okay, bundle them together, put it over here. Zero product property. Actually, I'll just put it right. We won't put it over the side. We'll put it right here. 0 product property. If A times B equals 0, so we can say, so either 2x minus 5 equals 0 or 3x plus 8 equals 0. And so we can follow this along. Actually, here's how I want to do this. I want to put them side by side. There we go. And we'll do a little or. So now we can do plus 5 plus 5. Sorry, I wanted my, there we go. Boop. And so we'll get 2x equals 5, divide by 2, divide by 2. And so we get x equals 5 halves. When we go over here, we do minus 8, boom. 3x equals negative 8, divide by 3, divide by 3, x equals negative 8/3. And there we go. We solved that equation. We figured out that if x is either of these fractions, that original equation that we started with, 4x squared plus 10 equals 50 minus x minus 2x squared, that equation will be true. If we plug in 5 halves here and 5 halves here, we'll get the same number on both the left and the right. That's what it means to solve an equation. Find an x value that makes the equation into a true equation. All right, that's our justification for factoring. And I'm realizing that we're getting on to the end of this session. So I spent a lot of time justifying factoring without explaining how to factor. But I think that justification is important because it will help us understand the factoring processes and make them feel less magical. If math feels like magic, that's your clue to ask a question. Try to and your question your question could just be, hey, factoring feels kind of like a magical process. You should I encourage you to let that feeling be a warning feeling. Math should be pretty mundane, actually. It should I don't want to say should. As you gain a mathematical understanding, it will in some ways lose that magical feeling. It gains it in other ways. Like it actually deepens a little bit, but those things that felt like magic before start to just feel very mundane and obvious. And that's good. That's actually it doesn't actually feel like a loss. It feels like a gain, I promise you. And so that can be a good guide to help you figure out what your questions are. And you could submit something like that. You could, you don't have to have a specific homework problem. You can just submit to me like, hey, the process of factoring has been feeling really magical lately. Like you just sort of do this thing and then the right answer pops out. And I'm just not really sure why. What I've been explaining here, this is what helps that magical feeling go away. You can totally understand a process and still have it feel completely opaque to you because you're just taking steps. You don't understand how one step is necessarily connected to the previous or how you would know to do those steps if somebody hadn't taught you, right? All of that stuff means that you're sort of doing the steps, but you're not understanding the math. All right. So techniques for factoring. We're going to so actually the very first thing I want to focus on is factor out the greatest common factor. GCF. So this is the first technique, and you should use it every time. Now, you may not be able to do anything with it every time, but you should attempt to use it every single time. So let's give ourselves an example. 9 x to the 8th minus 15x to the 6th minus 24x squared plus 6. Boom. Okay, so here's a polynomial, right? The very first thing we can notice is so 9, negative 15, negative 24, 6 are all divisible by 3. So we will take that common factor of 3. 3 times 3 is 9, so 3x to the 8th. 3 times negative 5 is negative 15. 3 times negative 8 is negative 24. 3 times positive 2 is 6. And so we factored out that 3. And now look, we've got slightly simpler coefficients, and it will make any further factoring we might do that. It will make that factoring easier. And notice what we've done. We factored this into a very simple coefficient, a numeral coefficient, a monomial, times this big long polynomial. Slightly simpler than the original one. So we could do that. Let's look at another one. Let's do so 21x to the 5th minus 7x to the 4th plus 49x to the 3rd. Okay, so this one, 21, negative 7, 49 are all divisible by 7. X to the 5th, x to the 4th, x to the 3rd are all divisible by x to the 3rd. That another way to say that is they all have at least 3 x's. So they all have 3 x's in common that we could take out, right? And so with this in mind, GCF is 7x cubed. And so that's what we'll do. We will rewrite this with 7x cubed on the outside. And then on the inside, 7 times 3 is 21. X cubed times x squared is x to the 5th. 7 times negative 1. So I'm just going to say negative because 1x is just x. And then x cubed times x is x to the 4th. And finally, 7 times positive 7 is positive 49. X cubed times 1 or times 7 is x cubed there. So that's completely factored out. And now check out what we have. So anytime you factor out a GCF is your first step, you will end up with a monomial on the outside times a polynomial with the same number of terms as your original polynomial on the inside. But notice how much simpler these coefficients are, right? Instead of 21, -7, 49, right? We just have a 3, a -1, and a 7. Way easier numbers to deal with. So that's part of the use, but this is still factoring, right? That's the important thing here. This is a term, this is a factor, and this is a factor. Um, right? Same thing up here. The 3 is a factor. I'm going to get rid of the underline because I don't want that to be confusing when people go back and look through this. 3 times this. So that's factoring. You're going to want to do that first, or you're going to want to attempt to do that first every time. Now, sometimes the greatest common factor is 1. Sometimes they don't all have an x, so you can't factor out any x's. Sometimes the coefficients don't have any factors in common. They're all prime numbers, or one of them's a prime number and the other two just don't have any factors in common, or whatever. So sometimes there just is no GCF, or the GCF is 1. And so that doesn't do you any good to factor out, which is fine. You still want to check, because when there is a GCF to factor out, it's very useful to factor out. And sometimes it's the only factoring you can do. Both of these, I don't think either of these remaining polynomials, I don't think those are factorable. I didn't set up these equations so that those equations would be factorable. And yeah, I did this. I know this one isn't, and I'm almost positive this one isn't. I could totally be wrong about this one up here. It might actually factor. It's complicated enough that I can't tell just by looking at it. Okay, so let's factor out the greatest common factor. That will work for all polynomials. So these are all. So these techniques that we're talking about right now. Well, actually, factor out the greatest common factor. That will work for anything. Right? It actually doesn't matter if it's a polynomial or not. I used polynomials, but it can have square roots in it. You can have all sorts of weird stuff. If they have any if all of the pieces have any factors in common, you can factor out that common factor from all of them and write it on the outside. Simplify the stuff left over while also obtaining a factor on the outside. Okay. So that is factor out the greatest common factor. So now this is specifically for quadratic polynomials. Use this is the quadratic polynomial technique. Right, this will work for every quadratic polynomial that is factorable. Not all of them are factorable. Right, just like there are just like there are numbers 13, 7 that are unfactorable because they're prime. They're polynomials and expressions that are prime. You can't factor them into smaller pieces, and so we regard them as prime. But for specifically quadratic polynomials, so just as a little note, right? Quadratic means the largest exponent is 2. There we go. Okay. So that's just a little note. A little definition note. So when we are, so those will look like A x squared plus bx plus c. So the a value has to be something. It can't be 0. That's what I'm trying to say. A can't be 0. So a does not equal 0. And that's it. That's the only thing. Because you have to have an x squared term for it to be quadratic. If it doesn't have an x squared term, it's not quadratic. If a is 0, then it's just some bx plus c. That's what we call linear. Notice, but b and c could both be 0, or either of them could be 0. So a quadratic could have one term, just the x squared term, and it could have the x squared term and just one of these, or both of them. But it couldn't have any more than that. So a quadratic is at most a trinomial. You can never have a quadratic. You could have a quadratic that has more pieces, but it means you could combine like terms and reduce it down to a trinomial. And in fact, you should. Okay, so step 1, multiply a times c. Let's use an example. Here, hold on. Let me make up a factorable quadratic, huh? Oops, wrong button. Let's see. Okay, so that's gonna equal. X minus 20. Okay. So this is assuming you've already factored out the greatest common factor. In fact, actually, this would work even if you haven't, but it's going to be, the numbers are going to be way easier to deal with if you have. So you don't have to do it, but it's going to assume that you have. And in fact, I didn't. So hold on, let me. Fine, let's do that. So that's going to be It's going to change this middle term. Okay, give me one sec. Let's do. Okay. So that's going to be 27. Yep. Okay. So our example here, we're getting low on time. I think this might be where we leave it, and we'll come back to this technique on Tuesday. I have a student right after this, so I can't go long on the stream. Otherwise, I totally would just go long on the stream. So let me write down this example, and then this is where we'll bring it back up. All right, 24x squared plus 11x minus 18. Pretty complicated quadratic. Most of the time when you're solving problems, you're not going to have to deal with quadratics even this complicated. And this isn't that complicated. The factors are once you see the factors, they're pretty simple. The numbers are pretty simple. So we will come back to this process. I was just about to start step one. Find A times C is what we'll call it. Okay, we will come back to that next time. Sorry I'm a little slow with my explanations and getting the stream started. As I honestly believe, as this gets going and gets some traction, I will find some efficiencies. It's kind of hard to find those efficiencies until you're doing it for real. But yeah, I'm just gonna keep doing what I'm doing. I think this is a helpful thing to have in the world, so I'm gonna keep doing what I'm doing. A reminder: the next session will be Tuesday at 9 p.m. That's the late stream. So join me back here, won't you? I hope you all have a good rest of your Sunday. I hope you get the rest of your homework done sufficiently. Please send me questions even now. Send questions anytime at all. That form is always available. I will check in on them probably periodically between streams. So yeah, keep sending in questions, or start sending in questions is what I should say probably. All right, I'm going to shut this down. Y'all have a really excellent rest of your Sunday. Bye now.